Good morning, good afternoon, good evening, depending where you're based. My name is Henrik Rexed and I'm welcoming you to the open source news of the 6th of May. Let's see the recent news of the open source community. OpenTelemetry web server module. Cisco has worked on an amazing initiative on OpenTelemetry. It's a web server module. For now, this web server module is limited to Apache. It will produce distributed traces from the traffic managed by Apache. It will be a very good way to get spans out of our web servers. NGINX would be the next candidate of this project. NGINX Ingress Controller had a similar feature, but using open tracing. A current issue is opened, so let's hope that our nginx ingress controller would soon produce also distributed traces. Pinpoint. Pinpoint is an APM tool for large-scale distributed systems written in Java, PHP, and Python. The project has been inspired by Dapr. Pinpoint provides a solution to help analyze the overall structure of the systems and how components within are connected by tracing transactions across distributed applications. Kubernetes. Kubernetes allows us to verify that our applications and Kubernetes cluster are working as expected. Kubernetes brings a new CRD, the Kubernetes check. It helps us to easily enable various synthetic tests and get Prometheus metrics out of it. Kubernetes comes with lots of useful checks already available to ensure the core functionality of our Kubernetes cluster. But of course, we can customize our synthetic checks to run checks against our applications. Go OpenTelemetry Auto Instrumentation Library. A new amazing news related to OpenTelemetry. There is now an automated instrumentation library for Go. This library is based on eBPF uprobes and will collect the various Go instructions. The deployment in Kubernetes is simple. We only need to add a sidecar container next to our application. Ballast. Kuber has built a really interesting project named Ballast. Ballast will capture the traffic using eBPF and then replay it. The project seems very interesting and promising for the performance engineering community. Robusta. Robusta is a new solution helping you to monitor your Kubernetes cluster and also deliver some audits against your cluster. Robusta provides lots of interesting features to be able to compare changes within your workload by providing a diff view. Out of the various news that we have presented today, there is one news that sounds really promising. It's the OpenTelemetry Auto Instrumentation Library for Go. This topic deserves to get more details, and for this, I have the honor and the pleasure to have Michael today with us that could help us to have a better understanding on this new instrumentation library. Hi, Michael.
Hey.
How are you doing today?
All well here, thank you. Yourself? All good?
Very good. Summer is coming. It sounds like we are all going to enjoy ourselves outside. I briefly presented the OpenTelemetry Auto Instrumentation Library for Go. Could you give us more details on how it works and what we could achieve with it?
Right. So let's step maybe a little bit before we get into that specific open source project we're going to discuss, and that is auto instrumentation versus manual instrumentation. So whatever workload you have and whatever programming language you have, in an ideal case, you would essentially get all the signals, be it traces or profiles or whatever, for free, right? It would automatically be generated. That is available for certain environments, for certain programming languages, but it also comes with certain limitations, right? It's kind of black box. you only get to a certain level. Like if you think of business related things, that usually is not included, but it is something that you get for free. So you certainly should consider that. Now, if you look at certain programming languages, think of Python, for example, where it's relatively straightforward to ingest that, to automatically get that part in and auto-instrument. Other languages, compiled languages that produce binaries, are probably not so easy from an engineering point of view, but you still want that. And the go-to mechanism nowadays, I would argue, is eBPF. eBPF being essentially, technically speaking, a Linux feature or syscall really, and there is some bits in the Linux kernel, technically a virtual machine that you're interacting with, where you say, here are some programs that you're running, that you're specifying in userland, which are injected, they are verified so that there are no endless loops and so on, and then they are executed in the kernel. So it's fast, it's very powerful, and it's safe. So that's great. But there are also certain limitations or certain requirements. So you really need to make sure that you have a very recent kernel, or relatively recent kernel. I believe it's above 4.18. There are certain other requirements. So for example, the kernel needs to support a compile once, run anywhere, everywhere core, and the BPF type format, BTF. And that's something that not every environment might support out of the box. So you need to look at exactly where are you running your workload, in what kind of environment. If you have a serverless environment, it might be a little bit more challenging. But if you can, from the compute side, fulfill these requirements, then an eBPF based solution is probably ideal, because it's not only for observability, you can also implement other things, be it networking related. Think of service mesh, for example, based on eBPF. You can do security related things there. So eBPF is a huge potential in this case.
You mentioned that it's not the right implementation for technology like Lambda functions or cloud functions. What about Kubernetes? If the community is utilizing OpenTelemetry Go auto-instrumentation library as a sidecar container to inject the agent to the code, I guess that if the community is using the right image and the right nodes, it should work properly.
Right. And again, that's why I mentioned serverless, right? If you control the data plane yourself, if you have full control over what Linux version, what Linux distribution, et cetera, is running, then absolutely you can do that, right? If the data plane itself, imagine the case, this is very often the case where you have a large enterprise, and you internally as a developer or DevOps team, you don't get to actually choose the Kubernetes version or data plane or whatever. You essentially just get access to it. You can maybe get access to some namespaces or whatever, but you can't really directly influence what is running or what are the dependencies in the data plane. You need to work with your internal infrastructure team to say like, hey, we would want to use that, so can you make sure that this version of Linux is installed and or kernel version is available, and that things like BTF are available. So that even gets harder if you have a serverless offering. Think of, I don't know, Fargate or Lambda or whatever, where you don't have access to the data plane, where you as a user, you have an API, but you can't pick the version of Linux there or whatever. So yeah, very much depends on the compute environment, the data plane in Kubernetes specifically here.
So it seems that eBPF is the right solution, helping us to instrument. Our community could wonder, what didn't we use eBPF for other languages? And why did we build all those SDK in other language? Is Go a language more designed for eBPF? Why don't we use eBPF for compiled language like C and C++?
Right. I would certainly argue that Go, in a sense, plays what, if you look in the cloud native ecosystem, a similar role. Many tools, many platforms are written in Go. If you think about Kubernetes and Docker and many of the HashiCorp things, or all of them, I believe, that are relevant there. If you think of Console and whatnot, and so Go really plays somewhat the role that C plays for initially for Unix and then for Linux. So this kind of like system level language that by default you probably would want to use, at least for things that are close to the infrastructure. Of course, there's also Rust in that space, but Go has this. If you look at the CNCF projects, for example, very widely used there. I don't really think that there's a technical reason why that hasn't been picked up in other programming languages. There is no good reason or limitation I'm aware of. It's really mainly of being aware of that opportunity, and given that so many things are written in Go in the cloud native land, it's kind of a natural starting place that people would go like, okay, can we do that with Go? And as I said, the only really hard requirement is eBPF, as earlier mentioned, in terms of kernel version, etc., symbols, BTF, and so on. Is that supported in your compute environment? And then, it doesn't really matter what kind of programming language you're using to actually develop, and you can benefit from eBPF, be it this specific open source project or be it other continuous profiling solutions, open source solutions, including Parka, Pyroscope, or CNCF Pixie as well.
I was going to mention that eBPF is also used in other solutions, especially with profiling platforms, such as Parka. And by looking around, there is more and more profiling solutions that are coming up in the market. So you mentioned Periscope and, of course, Parka. Is OpenTelemetry going to be extended with profiling as a new signal?
I absolutely believe so, and there is actually an OTAP, so an OpenTelemetry enhancement proposal out there, 139. We can probably link that in the show notes, that essentially suggests that, to say like, okay, OpenTelemetry as a whole, so both in the SDKs, the 11 programming language specific libraries, SDKs, and in the collector, should be able to deal with profiles, because profiles are it's not the 3 pillars, it's actually the 4 pillars or N pillars. Currently, we're in this, 3, so logs, metrics, traces. Moving forward, 2023, I would say, once we're done with logs in OpenTelemetry, I would certainly expect that the community starts focusing on profiles, and that's maybe not a bad thing in terms of moving parts there. It's not only the agent. There are other things. For example, think of how do you represent profiles on the wire, right? pprof being definitely a candidate there. By the way, I had a KubeCon talk, and next week there's a KubeCon Plus talk online about specifically this topic: continuous profiling, open source solutions. What are the challenges? And that's one of them. There are others, but I definitely not only hope, but definitely will also work in that direction to make sure that OpenTelemetry, in the fullness of time, supports profiling natively.
Awesome. I think profiling will probably bring lots of challenges and questions once we have the right support. I remember a few years back that when profiling was enabled in our environment, the overrate of the agents was pretty significant, and as a consequence, we were barely be able to use our system. So I guess there would be a way of configuring how much profiling details I need and how much I want to collect.
I think that's a challenge, but it's also the opportunity that, I think traditionally, profiling was more in this application performance monitoring space, where you would have that not necessarily in production. Whereas continuous profiling really suggests, hey, you can run that in production all the time. That's the continuous, right? You don't do that at one-off, capture profile and look at something, but you have that all the time because the footprint is relatively small. And you get this visibility that you can say exactly this line of code, right? It's this function. You can jump to it and say like, okay, I see one use case being, for example, you're releasing a new version or a new feature, and then you can compare how did that look before I released that new feature and how does it look now in terms of memory, CPU. Those are the two most widely supported, CPU and then memory, IO and other things definitely will follow. And that's, something that you're not doing after the fact or in development, but really in production live as you hit live traffic. Yeah.
Okay, so we clearly need to try it out. So call to the community. Let's try the continuous profiling solutions such as Periscope or Parka, and please share your experience, feedback. The project needs it to improve and be able to add more feature. And at the end of the day, if we have reliable and robust profiling solutions, it will have them naturally then back in OpenTelemetry.
Thank you.
Thanks, Michael, for your time. Thanks for your insight.
Awesome. Thank you.
See you soon for another open source news. Bye. How to drop and delete metrics in Prometheus. This blog, written by Timecodes, shares tips and tooling around metrics, leading to a more reliable operation for the popular monitoring tool Prometheus. Cloud Observability in Action. This book, Cloud Observability in Action, is written by Michael Blos and is currently available for reading, so please check it out. Observability for GitOps pipelines. With Work explains the difference between monitoring and observability by taking the use case of using observability for GitOps pipelines. The blocks explain the value of the various signals, the tooling that you could use, and it's also a good introduction to the solution with GitOps. Introducing trace tests, trace-based testing with OpenTelemetry. This blog introduces trace test, a tool which allows easily of creating end-to-end tests with a simple end-user interface.
Here is the weather forecast of the 6th of May. OpenTelemetry Java, version 1.13. Traces stable, metrics alpha. Logs is experimental. OpenTelemetry JavaScript, version 1.2.0, with experimental package on 0.28. Traces is stable. Metrics in development, logs in roadmap. OpenTelemetry.NET, version 1.2.0. Traces stable. Logs stable for iLogger and experimental for OTLP log exporter. Metrics is stable. OpenTelemetry Python, version 1.12.1 and 0.30b1. Tracing stable. Metrics alpha. Logs is experimental. OpenTelemetry Go, version 1.7.0. Traces stable. Metrics is in alpha. Logs is in dev. OpenTelemetry PHP, version 0.0.10 is pre-alpha version for tracing. Metrics is pre-alpha and logs not implemented. OpenTelemetry C++, version 1.3.0. Traces stable, metric experimental, and logs experimental. Erlang, version 1.0.2. Traces stable, metrics alpha, log not implemented. Rust 0.17.0. Traces is beta, metrics alpha, and logs not implemented. Swift version 1.1.2. Tracing beta, metrics alpha, logging not implemented. On the OpenTelemetry collector, version 0.50. Traces stable, metrics stable, and logs is in beta. OpenTelemetry operator, version 0.49. Metrics and traces and are stable, logs is in beta.
That's it for today's open source news of the 6th of May. If you enjoyed this content, don't forget to like and subscribe to the channel. See you soon for another open source news. Bye.